Hello class, we are in Unit 2 of Calculus. Day 1 is review of quadratics and polynomial functions. So let's look at quadratics first. We're looking at three forms. Standard form, which I don't think I'm going to get too much use today. Vertex form, very important. And then factored form. So example number 1 is that we are given the vertex. So I would use vertex form. Y equals a x plus 2 squared minus 5, and then I have another point. I can put it in for the x and the y. Okay, probably the biggest mistake I ever see is they do negative 4 plus 2, which is negative 2 squared, which is going to be 4, but then they do 4 minus 5. No, this is all together as one term. So it becomes negative 27 is equal to 4a minus 5. I add the 5, and a is negative 11 over 2. So my function is negative 11 over 2 x plus 2 squared minus 5. Problem number 2, I have the roots for the x-intercepts, so I'm going to use the factored form. Y equals a x minus 2 x plus 6. And I have another point to use. I'm going to put them in. Negative 24 equals a 0 minus 2, 0 plus 6 is negative 12a, a equals 2. So my function is 2 x minus 2 x plus 6. That is my function. But what if I wanted to ask a question? What's a vertex? Well, the vertex is in the middle of the two roots or x-intercepts, so that part of the vertex is going to be 2 plus negative 6 over 2, which is equal to negative 2. And I plug negative 2 in here. And when you plug the vertex into the x-intercept form, those two numbers inside parentheses should be opposites. Remember, they're multiplying each other. So I get negative 32. So my vertex is the point negative 2 comma negative 32. So I'm going to find the max area of this rectangle. I made dimensions, the length, top and bottom are x, and the width up and down is y. And this rectangle has perimeter of 40. So perimeter is just adding up all the sides. And if I solve for y, I get, well, let's see, 2y equals 80 minus 2x. So y equals 40 minus x. Now I want to find area. Well, area is just length times width, which is x times y. And my area formula is going to be x times 40 minus x. My domain for this, well, let's see, the most I can do for x is 40. If I make it x bigger than 40, my side y would be negative. So that's my domain. I'm going to put this on the graphing calculator to try to find the max. So I've typed this into the graphing calculator, and now I'm going to set the window. I do not hit graph. I hit the window because I know I have to reset the domain. Well, that's 40 and negative 10 to 100. I don't know if that's going to be big enough. I'm going to set the max to 500. Now I'm going to hit graph. And this is what the calculator looks like. I mean, the graph looks like. Now I'm going to find the max right here. Second trace number 4 max. I can use my cursor left and right. Or I could just type in a number. This is 0 through 40. Maybe I'll pick 30 as the right side. And my guess and the max is at x equals 20 and y equals 400. So I should answer the question, and the question is, what are the dimensions? Well, first of all, I have a max area of 400 square feet when x equals 20 feet, and if I plug 20 in here, that means my y value is also 20 feet. So my dimensions are 20 by 20. It is a square. So the next word problem, I have a 20 by 30 foot patio that I'm going to put a terrace strip, a uniform width terrace strip around this patio. And the width is always x. As you can see, I drew this picture. So this side here on the bottom is the 30 feet plus the x on each side. So this is 30 plus 2x. And this side here is going to be 20 plus 2x. The total area is now 1200, the 600 of the patio plus the 600 of the uniform strip. So I have area equals length times width is going to equal my 1200, or the 20 plus 2x times the 30 plus 2x is equal to 1200. Okay, as you can see, I went through and solved the rest of the problem. I expanded the binomials. I had to subtract the 1200 over because when I have an x squared problem, I have to set it equal to 0. I divided by 4 to make my life a little bit easier. And I factored it, and I got two solutions, 5 and negative 30. Obviously, negative 30 is impossible, so the width of the terrace strip is 5 feet. If you put 5 in here, this side becomes 40. This side would become 30. This side becomes 30 feet. And 40 times 30 feet is the 1200 square feet that we're looking for. Okay, we have this next problem where we're looking at an apartment complex that has 1,000 apartments total, but currently 600 are in rent at $800 per month. They want to increase their revenue. So a market survey shows that if they decrease the rent by $20 a month, they will result in 30 new leases. So revenue is just number of apartments times the rent. So currently we have 600 times 800, or about $480,000 a month in rent or in revenue. Well, what we're going to do is the number of apartments is going to go up. It's going to be the current 600 plus 30x. And the rent is going to go down. Right now it's 800, and we're going to subtract 20x. So if I use my revenue as apartments times rent, my new revenue equation is 600 plus 30x, 800 minus 20x. And if you think really hard what the domain is, the domain again is 0 through 40. I can't go bigger than x equals 40, otherwise I would be charging negative rent, which obviously will never happen. I'm going to put this in the graphing calculator. So I put this in the graphing calculator. I don't have to expand it. The calculator will handle it fine. Now I'm going to go to a window. I like my domain of 0 through 40, but my y value, 500 is not nearly enough. Right now we're at $480,000. This is going to go up, so maybe I should try maybe $600,000. I hit graph, and I get that look, and you can see it does max out. I'm going to do my second trace, number 4. So this is 0 through 40. My guess is around here, so I'm going to say my left side of the roundel is maybe like 2. My right side is maybe 20. Or you can use your arrows. See, I could use my arrows and move it. I hit enter, and here is my max. So you can see I put the graph on the notes here, and when x equals 10, my max revenue is $540,000. I went ahead and figured out how many apartments I would rent out and what the rent should be. And it's 900 apartments at $600 per month. And then 900 times 600 turns out to be my $540,000. And so what should I charge for rent? $600 a month. That would maximize my revenue. So review of polynomials. This is standard form where it's all expanded out and you have some a value times x raised to some power time plus another a value times x to the lower power, that's standard form. The most important term is this leading term, a sub n times x to the n. So what does this tell you? Well, when that a value up front is called the leading coefficient. When a is positive, the right side of the graph will go up to positive infinity, and if a is negative, the right side of the graph will go down to negative infinity. That's the far right side of the graph. The other thing we have is this n. N is called the degree. So whatever the highest exponent is, that's called the degree of the polynomial. Okay. When n is equal to even, the left side is the same as the right side. When n equals odd, the left side is opposite the right side. So if something is even, both sides either go up or both sides either go down. If n is odd, the opposite ends do opposite ways. The other thing we have for n, I'm going to have at most n x-intercepts on a graph, and at most n minus 1 turns, or bumps, or what I like to call peaks and valleys. Okay? Doesn't have to have exactly that number. It could be less than that, but it would have at most n x-intercepts or n minus 1 turns in the graph. The other thing we have is this last term here. A sub 0 is called the constant term because there's no variable with it. It's also the y-intercept. Good point to have, because it's always when x equals 0. All the other terms would cancel out. Well, let's see what I know from this example. This is not exactly the graph, it's just a possible sketch. 5x cubed is the leading term. 5 is positive. That means the right side goes up. X cubed, odd, left side goes down. Also means I have up to 3 x-intercepts. It means I have 2 turns in the graph. And the y-intercept right here is 5. I'll just put 5 right here. And this is a possible graph. That's one possibility. Next example. Okay, -3 means the right side goes down. X to the 4th means the left side also goes down. And -9 is the y-intercept, which I could just put here. So the right side goes down, the left side goes down, and I could have up to 4 x-intercepts and 3 turns. So 1 turn, 2 turns, 3 turns, and there we go. That is one possibility. It has 4 x-intercepts, doesn't have to. I could add something like this. could have no x-intercepts. That would be okay. Now when we have it in factored form, we have more details. We are starting to be given the x-intercepts, which are more details to these graphs. Before we had this general shape and maybe the y-intercept. Now I have x-intercepts. So inside the parentheses is called a factor. X minus r is a factor. The r is a root or an x-intercept. So for this example here, what I'm going to do, I'm going to bring it up. I had to be careful. So my leading term for this one would be 3 times x times negative x. That's that last term inside the parentheses, so I get negative 3x cubed, which means negative 3 means the right side goes down, cubed means the left side is opposite, it goes up. How do I find an x-intercept? I multiply out, I plug in x equals 0. I'm going to get x equals 0. I get, don't forget the 3 up front, 3 times 5 times 1 times 2. I get 30 as my x-intercept. As my y-intercept. My x-intercepts, let's see, first parentheses is negative 5, second parentheses is negative 1, last parentheses is 2. I get negative 5, negative 1, I get 2, I get 30 as my y-intercept, and I just go arrow, dot, 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 arrow, and you should be smooth. Don't get caught off that you have to go to that blue arrow, it just means it's going down. There is a possible look. This next one, again, my leading term is going to be 2x times x times x, which is 2x cubed. That means the right side goes up, the left side goes down. My y-intercept is going to plug in 0. I get 5 times negative 1 times negative 4. I get 20. And my x-intercepts are negative 5 over 2, 1 and 4. Negative 5 over 2, 1 and 4. And right here is my 20 for my y-intercept. I don't have to start at that arrow. It just means the left side starts down. Make a nice smooth graph. And there we go. That's what the graph, a possible look of that graph. Multiplicity is when we have exponents on the outside of the parentheses, and they're called repeated zeros. When it's raised to the first power, we don't write it down, and it goes through the x-axis very clean, like a line goes through. But if you put a squared, I call it a bounce. It will hit it like a parabola, x squared, and if there's a cubed, it would go through what I call a snake, or like a cubic function. It kind of squiggles through. And it would be the same thing for the 4th, 6th, 8th. Those would be bounces. If it was raised to the 5, 7, 9th, it would be a snake. So when I see this guy here, my leading term, I see an x squared times an x times an x to the 3rd. I get x to the 6th. There's actually a 1 up front. That means, so 1 means the right side goes up, and a 6 even power means the left side also goes up. My x-intercepts, change color here, my x-intercepts are negative 5, 1, and 4. But negative 5 has a squared on it, so I call it a bounce, and 4 has a cube on it, so I call it a snake. So negative 5 is going to be a bounce, 1 is going to go through nice, and then 4 is going to be a snake. Now I have to figure out my y-intercept by plugging in 0, and I get 5 squared times negative 1 times negative 4 cubed, and I get 1600. So up here, doesn't matter where you put it, is my 1600. I'm going to draw my graph. We're going from arrows through the dots, so I've got to go arrow. Oh, bounce. Hits off -5, bounces back up. Goes through 1600, goes through 1 clean, and comes through here like a snake. And there you go. The best I could do with a stylus. Okay. So I did all the details. My leading term is -8x to the 6, -8. Right side goes down. X to the 6 means the left side also goes down. My y-intercept was 500 when I plugged in 0. My x-intercepts are -5/2, 1 and 4. -5/2 was a snake. 1 is a bounce. So I'm just going to go something like this. And that's basically what the graph would look like, give or take. So these last 4 examples is based on factoring. You got to know how to factor. Those who had me before, I always ask, how good are you at factoring? My responses always get better. So when I do factoring, I look for certain patterns. First thing I look for is the greatest common factor. So like this first example, I see I can take out a 5x. I'm left with x squared minus 2x minus 8. And I factor more. I get x minus 4, x plus 2. And it says find the 0, so I'm setting this equal to 0. I get x equals, well, this first one is 0, the second one is 4, this last one is -2. And the way it works, since it was an x cubed problem, it should have 3 zeros, and it does. I see a 2x. I get x squared minus 2x plus 1. I get 2x, x minus 1 squared. And this one I only get 2 solutions of 0 and 1. But 1 is a bounce, also known as, this is a bounce, or a double root. So there are 3 roots in this problem. Okay, the last 2 examples are a little bit special patterns here. I took out a 25x. I get the x squared minus 4. Difference of 2 squares. That should be a 5-second decision. X plus 2x minus 2. The last one I took out the 3x. And I had the 2x squared plus 5x minus 3. You can just factor it. That 2x squared would make it a little bit more difficult. I set up the little x pattern on the side here. And you need 2 numbers. I did 2 times -3, so you need 2 numbers that multiply. -6, but add to 5, the middle term. I set it up. And there are your solutions. Okay, thank you for watching this video.